Welcome to our next lesson. Within our second chapter, we will be talking about formulas and extending what we use in previous lessons to problem solving. So formulas show up a lot. They describe relationships between measured quantities, distance, time, weight, length, money, anything that can be measured and quantified. We can represent these various relationships using formulas. The chart on the right shows a lot of different formulas, or not a lot, but it shows a few common formulas and what these things represent. This is not by any means an exhaustive list, but it gives a good idea of some common formulas that we may see. Solving for a variable is when we take an equation's specific variable and isolate it to one side of the equation so that there are no other variables there are no others of that variable in the equation. So we want to get one of the variables of what there might be many and get it isolated to one side, and then everything else, including all the other variables, are on the other side of our equation. So for example, the d in the distance formula is already isolated, but we can also solve for r by rewriting the equation in the form r equals d divided by t. So we're going to do that for each of our different equations here. Now, there's no hard and fast, clean-cut set of rules that we can use. It's more of a combination of using our addition property of equality as well as our multiplication property of equality in order to manipulate the equation based on the setting that we're given. Now, there are a few different ways that we can work through the isolating. I'm going to try and show one of the more efficient ways for each of the equations. But if your process varies slightly and you still end up with the same result, then there should not be a problem. As long as you are applying the addition properties correctly and the multiplication property correctly, you should not run into an issue. So we want to solve for h in this equation, which means we need to take h and get h by itself, meaning we need to move the L and the W. So if we look at this equation and really break down what's happening, L is being multiplied by W and being multiplied by H. Well, in order to get H by itself and move the L and W, we have to undo the multiplication. Well, the way that we undo multiplication is through division. So we can divide our equation by L and we can divide it by W. And if we do that on one side, we have to do it on the other. So here we have three factors being multiplied together. If I divide by L, L divided by L is 1, W divided by W is 1. That leaves us with just H on the right-hand side. So H is set equal to V over LW. Next, we've got a linear equation in two variables, x and y. And when we have equations like this, it is very common that we will solve for y and isolate y. That's because when we deal with linear equations, we usually want the form of the equation y equals mx plus b. And so we're usually isolating y in order to make that happen. So to go through that, again, we look and we identify the operations that we have. Well, y is being multiplied by 3, and it's also being subtracted by 2x to equal 7. So in order to isolate it, first we need to move the term. We will need to get rid of the negative 2x by adding 2x to both sides of our equation. That will eliminate the 2x, leaving us with 3 times y equals 2x plus 7. These are not like terms, so we can't add them. Also, conversely, if you wanted to write it as 7 plus 2x, that would still be correct. It would not be wrong. Either one of these is fine. Then in order to get rid of the 3 as our coefficient, we undo multiplication by dividing. So there's two ways we can approach this division. We can divide the left and the right sides as a whole. When we cancel, that leaves us with y equals 2x plus 7 divided by 3 as one big fraction. The other way that we can approach it, and something that we will end up doing more often in the future, is if I have 3 times y equals 2x plus 7, I can divide each term in the equation by 3. That cancels out on the left, leaving me with y equals 2/3 x plus 7/3. These two equations are equivalent. Now, the one on the right is in our y equals mx plus b notation, which is something we will be using more often. But for now, the equation on the left is a little bit faster and is still sufficient. So either one is fine. Now let's go ahead and look at C. This one's going to be a little bit different. We're solving for B, and B is inside of our grouping. So we have two ways that we could approach this problem. We could get rid of our grouping by using distributive property, or we could be a little bit more clever. And since distributive property is essentially multiplication, we can undo these multiplications through division. We can divide both sides of our equation by 1/2, okay, which is the same as multiplying by 2. Again, we can get rid of fractions by multiplying by 2, by the least common denominator. So dividing by 1/2 eliminates the fraction on the right side. A number divided by 1/2 is the same as 2 times that value. And we have b plus b times h. And then again, we want to get rid of this multiplication, so instead of distributing, we will divide again, this time by h. That canceled out the h, leaving us with 2a over h equals b plus b. And then if we want to get this lowercase b by itself, all we have to do is subtract the uppercase b, and we're left with 2a over h minus b equals b. Now note, in formulas, we can use the same letter and use different capitalization to represent a different value. So uppercase b and lowercase b are two distinct values. So when you're writing your formulas, the case matters, and you need to pay attention to that. If the formula gives you a lowercase x or a lowercase y, they must remain lowercase throughout the entirety of the equation. Same thing if we get an uppercase a or an uppercase b, they must remain uppercase through the entirety of the solving process. Now our last one, we're going to use a similar idea that we did on the last one. But the difference that I want you to note is that what we are solving for appears twice in our formula. And we don't want it to be there twice, we only want it to show up once. And so if you'll recall from a previous lesson when we talked about combining like terms, when we notice that we have a common factor within multiple terms, we can create a grouping and we can factor out that common term so that it doesn't appear twice, but now only appears once. So we end up with a equals, and as the process of factoring, what we're doing is we're essentially dividing each term by that factor in order to bring it to the outside. So we still have our grouping symbol. P is now on the outside, and when we divide each term by P divided by itself is 1, plus PRT divided by P is just RT. To see why this works, let's work backwards again. If I take the expression P times 1 plus RT, and I apply my distributive property here and here, we see that it equates back to the original expression that we had in our formula. So the distributive property can be undone in order to pull out a common factor, just as it can take a factor and distribute it across addition or subtraction. So now that we have just one P, and note that that P is being multiplied by a grouping. If I need to remove that grouping, I can divide my entire equation by that grouping in its entirety. That grouping symbol makes our life a whole lot easier. So when we divide, we remove the grouping from the right side, and we're left with P equals A over 1 plus RT.